In this video, we are taking a look at how client connects to a non-default frequency. In this case, -1337, while the default frequency is -1. And if you take a look at the class diagram, we again start from the control fragment where the user clicks on the connect button, the call is forwarded to the model, and then to the control implementation. Control implementation, as before, creates the connection reader and writer objects, and when the reader creates a connection to the server, the state of the protocol is then connected. The connection reader is then notifying the control implementation about that state change using the handler. After this, when the connection has been made, the server immediately sends the default frequency message to the client, and then connection reader handles that again by using the handler to notify the protocol implementation with the handler. But if the client connects with a non-default frequency, then the protocol implementation has information that another frequency should be used. In this case, the protocol implementation then compares the -1, what was received from the server, with the one that should be used, and then notices that they are different values. It then sends the new frequency with the connection reader to the server. The server then handles that frequency change and will then again confirm the client that the new frequency is now in use by sending back as a confirmation the new frequency number. Again, connection reader reads that message and uses the handler to notify the protocol implementation that now we have changed the frequency to the one the user wants actually to use. And the protocol listener interface, which model implements, then notifies all the observers that we are now ready to send and receive messages. So when I click the connect button, we can then take a look at how all this happens in the code level. But before that, I need to launch the server since I still don't have it running. Sorry. Okay, so let's connect. And what we do here is that we see that the breakpoint in the control fragments on click was met, where we call the connect method of the interface. You can see the server's address, the port number, and now the frequency that the user wants to use, -1337. All these were read from the settings of the application. Now we see how the call is forwarded to the protocol implementation, which now will save all the values that came in the parameters, including the frequency, and current is -1 because that's what it's initialized to in the class. Now we read it from the settings, and now we go into send frequency after setting the value. But now the send frequency doesn't actually send anything, obviously, because we are not yet connected. So what happens here is that we see that current state disconnected, not line down, which is the only valid state where frequency can be changed. So we just go through all that code and do nothing. And then here we will launch the reader and the writer, and we will then see sorry what is happening with the in the initialization of the connection. So the first breakpoint is here in connection reader run thread function, where we initialize the connection by creating the socket and calling connect, and then we initialize the session initialization time used in the timestamp calculations, create the input and output stream object, set the lineup by user and server to false, so initialize all the necessary member variables, and then change the protocol state to connected at this point. And then what happens is that the protocol implementation run is called and the state is set to connected. That line here, lineup by server, is actually not needed. I already did that in the connection initialization thread function, so I will take that away. Anyways, then release the log and tell all the listeners or the observers that we have now changed the state to connected. And immediately we meet the breakpoint here in the connection reader's read loop, because the server immediately sends us the default frequency as specified by the protocol specifications. So as you can see, the value that we got is -1, and we then need to handle the state change because of that. So we got the confirmation message that the frequency is what we use now, and that means that we change the state of the protocol to line down. So again, when we resume the application, we can now see how it is handled here in the protocol implementation run. We are setting the line state to down, but because the current state is connected, what we do here is a bit different than what we do there when we change from line up to line down. There is no need to have an else if structure there, because the only thing that actually can happen here if you implement everything correctly is that the else branch is reached when the line is actually set from line up to line down. So there's no need for else if branch. Okay, so the upper branch is handling the situation where the state was connected. So we actually do the state change and release the log as we should do here. Then we compare the current frequency that the user wants to use to the one the server sent us, and they are different. Of course, because user has set the frequency to -1337 and the server always sends the default frequency. So in that case, we have to send the server a message that no, we want to use the other one, the other frequency 1337. So send frequency implements that. And now again we are changing the state, so we need to use the log for that. We check if the state is line down. It is, because we got the -1 message while connected. We switched the state to connected, but saw there that we need to actually change the frequency. So we can then continue sending the new frequency to the server. Okay, how that happens is like sending line up and line down, which we saw in a separate video. We store the value to be sent here in the integer -1337, and then open the condition variable so that the writer thread then stops waiting and actually then starts sending the information to the server side. And now we also have to change the state again to connected, back to connected, because that is what the protocol specifications say. You can only send frequency change when in line down, and while that change is handled, you have to wait in the connected state. That means that when you are in the connected state, you cannot send line up and line down messages either. Okay, you saw that in the previous videos. Line down and line up are only sent when state is line down or line up correspondingly. Okay, and then notify the listener and the observers that we are now in connected state. Let's resume and see what happens. Again, we are in the breakpoint of read loop, because now the server has sent us a confirmation that we are now in the new frequency. So when you check out the value there, what we got from the server is -1337. So now we got the confirmation of the frequency change, and again we change the protocol state to line down. and then we can continue. User could start sending line up and line down messages. But let's resume and see how that is then handled again by the protocol implementation's run method. Here we see that the state is again connected. We change the state and then release the log and see that now we have same values here in the current frequency and what we got from the server. So we can now notify the user that we actually now have changed the frequency. And when we resume the application, we can now see that it is actually running there. And we could start sending line up and line down messages to the server side with this new frequency that we are now using. Okay, so that's basically what happens there. We could also now see what happens when we are already connected and then the user decides to change the frequency. Let's say back to the default frequency -1. And the difference is that now we are already connected. Okay, we had a breakpoint here at set frequency, so now we are taking a look at what happens. The current frequency is again different than what the user now wants to use. So we save it to the member variable and then call send frequency as we did before when launching or creating the connection. But now we have the connection already there, so this time it will be sent then immediately. So again, log is needed because state is changing from line down to connected. Again, we are using the connection writer in the same way than before. Open the condition variable and remember to set the current state to connected because we need to be in that state waiting for the server to confirm that we are actually on the new frequency. And server did it quite quickly. So again, you can see how it is handled. As before, when we were connecting, we got the new frequency value -1. We again change the state now from connected to line down. Change the protocol state method is called, and here change the state, release the log, check that now we have same value in the current frequency and the one the server sent. So notify the listener who notifies all the observers, the fragments and so on, that now we have again achieved a new state. So now we could then start sending with this frequency. If we take a look at what it does, all this looks like on the server side, you can see that our client connected here. Server created the default frequency -1 for it because it was the first client that connected. Count of frequency client is now 1, and then the server sent the client the default frequency number as I described earlier. Then the client application saw that actually the user wanted to use a different frequency. The server receives that message. Now frequency 1 lost that client. On the client it created the new frequency 1337. Then server sends the confirmation message about that to the client application. Now you have this frequency number. Then I changed it manually. Frequency is received to the server side. So now the frequency 1337 lost that only client it had. And since now frequency 1 got the new client, it has now a new user, and again the server sent the confirmation message about that frequency change to the client application. So that is how it looks like on the server side. Okay, so that is how the frequency change is happening when either connecting or when the application is already connected to the server side.